Day 236 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we're at day 236, and today we have question number 173, binary search tree iterator. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible, so let's get into it. The question says, implement the BST iterator class that represents an iterator over the in-order traversal of a binary tree. BST iterator tree node root initializes an object of the BST iterator class. The root of the BST is given as part of the constructor. The pointer should be initialized to a non-existent number smaller than any element in the BST. The has next function is a boolean which will return true if there exists a number in the traversal to the right of the pointer, otherwise returns false. The next function moves the pointer to the right, then returns the number at the pointer. Notice that by initializing the pointer to a non-existent smallest number, the first call to next will return the smallest element in the BST. You should assume that the next call will always be valid. That is, there will be at least a next number in the in-order traversal where next is called. So let's break that down. Let's look at example one so we can see what they mean. Let's go through example one. So in example one, we have the input equals the BST iterator, which is where we initialize it. Then it's next, or it's an array of strings or function calls. Then we call next, then we call next, then we call has next, then we call next again, then we call has next, then we call next, then we call has next, then we call next, then we call next. This right here is a representation of the binary tree that we'll be working with. So it goes 7, which is the root, then it goes 3 right here, then it goes 15, then null, because remember, we're going left to right, so null, null. So that's where these two nulls come from. Then we have 9 and 20 right here. Boom. Then the rest are just blank arrays. Now the output goes null 3, 7, true 9, true 15, true 20, and false. So if y'all are confused as to how they got this output from this input, let's get into it. So the first thing I'm going to do is I'm going to copy and paste this over here so we could go through it and I could make it make sense for y'all. So we're going to copy and paste that. Boom. Then we're going to come over here. We'll copy and paste this as well. Boom. That should be a 2D array. So let's just make sure we add an extra square bracket before we paste that, like so. Boom. Bring that over. Then this is the output right here. Let me copy and paste that as well, because it's a lot to it's a lot to take in. You could handle it. Oh, it's a lot to handle, right? So let me copy and paste all this so we can work with it and I can show you step by step of what's going on. So just so we know, that is the output. All right, boom, boom. My bad, y'all. All right, let's get into it. So the first thing we are going to do is we are just going to initialize the BST iterator function, right? Or the conductor. And all the conductor is initialized, right? Where we initialize it. So, and we need to remember that it represents we need to iterate through it in an in-order traversal. So first thing we need to know is what an in-order traversal is, right? So in-order traversal is just a traversal where we traverse the left subtree, which would be this 3. Then we traverse the root. Then we traverse the right subtree, and then we go 9. But it go like 9, 15, 20, right? For the right subtree. But overall, it go 3, 7, 9, 15, 20. That's what an in-order traversal would look like. So now that we know how we need to traverse this, let's figure out how they got this output, right? So first, we initialize it, boom. So we can initialize it. We could get rid of this and this null. That's where this null comes from. So we could get rid of this null. Excuse me, y'all. We get rid of this null as well, right? We'll go right here. Then we call the next. Let's get rid of this comma. So then we call the next. So we initialize it. The next would be the 3. That's the first element that we're looking at, right? So that's the next when we start. at the first next is going to be the first element in the in order traversal. So that's where this 3 comes from. That's why the output is 3. Boom. Remember, this is the binary tree. This is what the binary tree looks like, but we're going to look at this picture because this could get confusing. So, matter of fact, let me just delete this so you don't get confused, because that's the binary tree, but not the in order traversal, right? So the next, first we call next, we're doing the in order traversal. So the very first thing we're going to traverse is the left subtree. That's where we get this 3 because there's only one value in the left subtree. So boom, we put a 3 right here. That's why the output has 3. So we get rid of that. We still moving. We moving on down the input. We moving on down the input. So then we call next again. So remember, the next moves the pointer to the right and then returns the value. So that's why we are moving the pointer to the right. We go from 3 to 7 because that's next. Then we return the value. The value is 7. Boom. So then we could get rid of this. That's where the 7 came from. Then, just so y'all can see this as well. Then, boom, we return 7. Then we call the has next. The has next function returns true if there exists a number in the traversal to the right of the pointer, otherwise returns false. So as long as there's more numbers to traverse, then the next is going to have there's going to be a traversal to the right pointer, right? So the next would be 9, but we just want to see if there has a next, right? So the has next is true because there's a next, there's more to traverse, right? So we could get rid of this. That's where the has next comes from. Come down here so y'all can see this as well. So then we get rid of this has next. Boom. After that, now we're calling next. So now we want to return the value of the next node that we're traversing. The next node would be 9 because remember, doing in order traversal. So it goes 3, 7, then we do 9, 15, 20. In this case, the next is 9, so we return the value of 9. Now we call has next to see if there's more to traverse. And the answer, it returns true because there's more elements to traverse, right? So we can return true after we call the has next. Boom. Then after we call the has next, now we call next. When we call next, we want to return a value after the 9, right? Because before there was just has next, so we didn't have to return any value. Now we returning the value. The next after 9 would be 15, so that's where this 15 comes from. Boom. Then we call has next again. We want to see if there's another value that we can traverse or another node. The output is true because we still have 20 left, right? So we put the true right there. Boom. Now we call next, so we want to know what that next node's value is, and it's 20. So that's why we return the 20. Boom, just like that. Then we call has next. There's no other nodes to traverse. That's the end. There's no other right pointer to look at. So we return false because 20 was the last node in our in order traversal. So now when we call has next, we return false. Boom. So that's how the question works. That's what the example was trying to explain. Hope that made sense to y'all. So now that we understand the question, let's get into the fun part, the actual solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check out that link in the description. And then after you do that, go ahead and like, comment, and subscribe. So let's see how we're going to do this. First thing we are going to do is we are going to declare a private variable by saying call stack, and we're just going to do that by saying private var stack, and that is going to be an array of integers just like so. And the stack array is going to hold the in order traversal of the BST or of the binary search tree. So this is what we're going to be able to iterate through as we're trying to find the next element or the next node in the binary search tree. Then we're going to declare another variable, private variable called private. We're going to say private var index. That's colon. That's going to be an integer. And this index, this is going to keep track of the position of the current element being assessed in the stack. So we just need this index so we'll be able to iterate through the stack and know which element we're on. Now we need to initialize these things in the constructor, right? So To do that, we just need to initialize. We'll say self.stack equals a blank array. Then we're going to say self.index equals 0, right? Because remember, we want to, what does it say? Notice we need to initialize the pointer to a non-existent smallest number. The first call, the next will return the smallest number in the BST, right? So we're initializing with 0. Boom, that's the smallest number that we can, right? So boom, now after we do that, we're not done yet. We're just getting started, because now we need to create a helper function that's going to help us to perform the in order traversal of the binary tree, right? So in order to do that, we're going to say private func. We could just call it traverse. Open up the parentheses, underscore node, colon. That's going to be a tree node. Put the question mark, come outside of that, open up the brackets. We are going to say guard let node equal node, else we can just return. So else, open up the brackets, return. So if the current node is nil, we can just return right there, and we don't need to keep going any further. If it's not nil, then that means we need to recursively traverse the left node. So in order to do that, we're just going to say call traverse, which is the function we just created. That's where the recursion comes in. So we're going to say traverse, open up the parentheses, node dot left. Then we're going to come underneath that. Now we need to add the current node's value to the stack. So we're just going to say stack dot append, open up the parentheses, node dot val. Now we need to recursively traverse the right subtree, right? So in order to do that, we're just going to say traverse dot node, parentheses, node dot right. Because, we need to traverse the right subtree. So now, after we do that, we need to initialize this. So we're going to say self dot traverse, open up the parentheses, root, just like so. Now we're almost done, y'all. Now we just need to work with the next function and the has next function. So in order to do the next function, which will get the next number in the binary search tree, or the next smallest number for us, we're going to say index plus equals 1. Boom, because what this is going to do, this is going to append the nodes in ascending order. So this is just going to go from, when we call the next function, we're just going to go from smallest number to biggest number. So now we're just going to say index plus 1 plus equals 1. And then we're going to say, which is going to move to the next index. Then we're going to say return stack, open up the square brackets, index minus 1. And this is going to return the element of the previous index, right? So boom. After we do that, now we need to call the write the function for the has next, right? Which is going to check if there are more elements in the BST to iterate over. So in order to do that, all we have to do is see if index is less than stack.count. And if it is, then we know that there are more elements to traverse. And it's just going to return true or false for us, because it returns a bool. Now, that should be all she wrote, y'all. Let's run it, see how it runs. Make sure it runs properly. And it's accepted, so let's submit it. Make sure it stays accepted. Let's see. And look at that, y'all. 3 milliseconds beats 77.87% of users with Swift. Not too bad at all, y'all. We'll get these numbers up as we go further down our LeetCode journey. Right now, we just want to get to a point where we're able to answer a question that is presented to us. And I feel like this is a pretty simple and easy solution to understand and remember and internalize everything that we learned today, y'all. So all we're doing is traversing the left node, then we're appending the node, then we're traversing the right node. And if we want to move to the next node, all we're doing is incrementing the index and returning the index. And to see if there's a hash next function, we're just seeing if the index is less than the stack.count, y'all. And that will help us solve that problem. That's all we need to do, y'all. So I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. Oh yeah, before we leave though, get one more look at the code, And that's all. Hope to see y'all here tomorrow. See y'all then.